x changes to x plus delta x since x is connected with y by y equal to fx, therefore y will also change. In this case, when limiting value of delta y by delta x as delta x tends to 0 is called derivative of this limiting value. Now we are going to extend our idea of limit. That means we are going to new topic, differentiation. I start like this. Let y equal to fx be a function which is of course defined, means continuous, and will have definite value, we call single value, within the given interval. Also we say like this, within the domain of definition of this function, and say x changes to x plus delta x, delta x written like this, or delta x, and later we shall replace this delta x or this delta x by h. X changes to x plus delta x since x is connected with y by y equal to fx, therefore y will also change, and say the changed value of y is y plus delta y or y plus delta y, that will be f of x plus delta x. Therefore, change in y is delta y, that is equal to f of x plus delta x minus y, that is f of x plus delta x minus fx. Next we consider the ratio or quotient delta y by delta x. I repeat, x changes to x plus delta x, corresponding value of y is, or fx is, y plus delta y, that means f of x plus delta x. From this, delta y is f of x plus delta x minus y, that is f of x plus delta x minus fx. Now we consider this ratio or this quotient, then it will be now what will happen if the change in x, that is delta x, delta x is very small, we represent that by writing delta x tends to 0, or h tends to 0. Then this quotient or this ratio will be limit delta x tends to 0, delta y by delta x. Thus, this is a limit. Delta x tends to 0 means change in x is very small. We also say x is infinitesimally small. Change in x is infinitesimally small. In that case, this quotient or this ratio is this. That means we kept a limit. That means we have to use the concept of limit. And in this case, when limiting value of delta y by delta x as delta x tends to 0 is called derivative of this limiting value is called derivative of y or fx. Also, the other term is differential coefficient. Differential coefficient of y or fx. Therefore, derivative of function y equal to fx is nothing but a limit, this limit, and this limit is represented by, or derivative of fx is represented by the symbol dy dx or f dash x or y dash or y1 or here d is ddx and this is called derivative of fx. Therefore, dy dx is limit delta x tends to 0, delta y by delta x, that is limit delta x tends to 0, f of x plus delta x minus fx by delta x. Therefore, derivative of the function fx or differential coefficient of the function fx is this limit, limiting value of delta y by delta x, where delta y is the change in y corresponding to the change of delta x, which is the change in x, and this change in x is very small, infinitesimally small. Now this is a limit. Therefore, as per the concept of limit, this limit will exist if left hand limit and right hand limit both exist. That means both are finite and equal. Naturally, dy dx will exist if limit h tends to 0 minus f of x plus h minus fx by h. Now I write here delta x equal to h, therefore the revised form will be limit h tends to 0 f of x plus h minus fx by h. This is left hand limit and this is represented by L f dash x, left hand limit. If this and limit h tends to 0 plus f of x plus h minus fx by h, which is right hand derivative denoted by the symbol. Left hand derivative, this is right hand derivative. Both must be equal. Of course, finite. Therefore, derivative of a function y or fx is a limit, this one, and this limit will exist or derivative will exist if both the left hand limits, which are called left hand derivative and right hand derivative, be equal. Now, derivative of a function at a certain point derivative of fx at x equal to 1, x equal to a at a certain point will be represented by limit h tends to 0 minus 0 f of a plus h minus fa by h is finite. Derivative of x at x equal to a is this one. Now again this one is a limit, therefore this limit will exist if condition of existence of f dash a, as discussed in limit L f dash a be equal to R f dash a. We call it left hand derivative and this one is right hand derivative. The other symbol is f dash a minus 0 and this is f dash a plus 0. Therefore, condition of existence of derivative of the function fx at x equal to is that existence of the limit this, and this limit will exist if left hand derivative and right hand derivative as x tends to a both be finite and equal. Therefore, the condition is this.